There are certain objects in the night sky that feel less like stars, and more like ticking clocks. Betelgeuse has always been one of them. For centuries, it glowed from the shoulder of Orion like a silent warning hanging above Earth. Massive. Ancient. Unstable. Astronomers have long known that Betelgeuse is living on borrowed time. One day, the giant red star will die in a supernova powerful enough to briefly outshine entire galaxies. For most people, that idea always sounded distant. Something dramatic enough for documentaries and science fiction, but not something humanity would realistically witness. Then the star dimmed. Not slightly. Not in a way only giant observatories could detect. It dimmed so dramatically that ordinary people looking at Orion noticed something was wrong. And ever since that moment, Betelgeuse has felt different. Not like a star peacefully aging in deep space, but like a giant celestial engine beginning to lose control of itself while the world watches. Betelgeuse is one of the largest stars visible to the naked eye. A red supergiant so enormous that if it replaced our Sun, its outer atmosphere would stretch far beyond the orbit of Mars and deep toward Jupiter. It burns with staggering luminosity. Tens of thousands of times brighter than the Sun. And in cosmic terms, it is close. Close enough that astronomers have spent decades discussing its eventual death as one of the most important future sky events humanity could ever witness. That is why the Great Dimming shocked the scientific world so deeply. Between late 2019 and early 2020, Betelgeuse suddenly lost a huge percentage of its brightness. The change was so dramatic that some scientists openly wondered whether the star had entered the beginning of its final collapse. For the first time, a star that had always seemed permanent looked wounded. And psychologically, that mattered. The night sky is supposed to feel stable. Constellations are supposed to remain unchanged throughout a human lifetime. But suddenly, one of the most recognizable stars on Earth appeared to be fading in real time. At first, astronomers proposed a relatively safe explanation. Perhaps Betelgeuse had simply ejected a cloud of dust that drifted between the star and Earth, temporarily blocking some of its light. That interpretation made the event strange, but survivable. The star itself would still be fundamentally stable. The dimming would mostly be an accident of perspective. But as researchers continued studying the event, the story became far more unsettling. Evidence suggested the dust cloud may not have been random at all. Instead, Betelgeuse appeared to have experienced an enormous surface mass ejection. A violent eruption so immense that it dwarfed anything our Sun could produce. A colossal amount of stellar material seems to have been blasted away from the star's surface. That material expanded outward, cooled, and condensed into dust, creating the strange dark veil observed from Earth. And that distinction changes everything. Because if the dust had simply drifted into our line of sight, the event would mostly be optical. But if the dust was created by Betelgeuse violently throwing pieces of itself into space, then the dimming becomes evidence of instability deep within the star itself. In other words, Betelgeuse was not merely hidden. It may have been tearing itself apart. That is where James Webb Space Telescope becomes crucial. Webb observes the universe primarily in infrared wavelengths. And infrared is exactly where cooling dust and expelled stellar material begin revealing their secrets. Visible light telescopes can show the surface of a star. But Webb can trace the aftermath surrounding it. The cooling debris. The expanding clouds. The thermal fingerprints left behind after violent eruptions. Webb is not simply observing what Betelgeuse looks like. It is observing what Betelgeuse leaves behind when it sheds parts of itself into space. That matters because red supergiants remain one of the least understood stages of stellar evolution. Astronomers know how stars like Betelgeuse eventually die. As nuclear fusion progresses, lighter elements become exhausted. Hydrogen fusion gives way to helium. Helium leads to heavier burning stages. Eventually, iron begins, and iron changes everything. Unlike lighter elements, iron fusion does not produce energy that supports the star against gravity. Once enough iron builds up, the core collapses catastrophically. A supernova follows. That broad picture is understood. But the path leading to that collapse remains full of mysteries. And Betelgeuse may be revealing those mysteries in real time. The star does not behave calmly. Its atmosphere pulses. Its outer layers expand and contract. Massive convection cells boil across its surface. And increasingly, Betelgeuse appears to eject material in huge uneven episodes rather than through smooth gradual loss. Its outer atmosphere is chaotic, dynamic, and difficult to model accurately. That is why every new observation feels emotionally charged. Astronomers are not watching Betelgeuse simply because it is famous. They are watching because it may be exposing the exact physics that determine how giant stars die. The Great Dimming may not have been the supernova itself. But it may have been a glimpse of the instability that comes before one. And that possibility changes how people see the star. Because once a celestial object begins behaving unpredictably on human timescales, it stops feeling distant. Whenever Betelgeuse is discussed, one question always follows. If it explodes, what happens to Earth? Fortunately, current science suggests humanity would survive safely. Betelgeuse is estimated to be hundreds of light years away, far enough that its supernova should not destroy Earth's atmosphere or cause mass extinction. But survival does not mean insignificance. If Betelgeuse explodes, it could become one of the greatest sky events in recorded human history. For weeks or even months, the supernova could rival the brightness of the moon. It might even become visible during daytime. The familiar shape of Orion would transform before human eyes. A star that had glowed steadily for thousands of years would suddenly erupt into an object bright enough to dominate the sky. No human civilization in the modern technological era has ever witnessed a nearby supernova like that directly. Humanity would watch the universe change in real time. And that is what gives this story its strange emotional power. Betelgeuse is close enough to matter. Large enough to terrify. And unstable enough to keep astronomers awake at night. One of the strangest developments after the Great Dimming was that Betelgeuse did not simply return to normal behavior. Its pulsation patterns appeared altered. For decades, astronomers had tracked rhythmic cycles in the star's brightness, almost like the breathing of a living organism. But after the dimming event, one of those long-observed cycles appeared disrupted. That detail deeply unsettled researchers. Because stars like Betelgeuse are not solid static objects. Their outer layers pulse continuously. They expand, contract, convect, and tremble. Those rhythms reflect the internal state of the star itself. So when one of the most famous red supergiants in the sky suddenly loses part of its natural rhythm, scientists pay attention. It suggests the star may have been physically disturbed. Like a bell struck hard enough to change the way it rings. And psychologically, that image is difficult to ignore. A wounded giant star vibrating differently after ejecting enormous amounts of material into space. That does not feel calm. It feels unstable. Again, this is where Webb becomes critically important. Infrared observations allow astronomers to follow the expanding debris around Betelgeuse with extraordinary detail. Every new dust cloud. Every shell of expelled material. Every thermal structure spreading outward from the star becomes another clue. Webb may not witness the final explosion itself, but it is perfectly positioned to document the violent road leading toward it. And the deeper astronomers look, the more Betelgeuse begins to feel less like a distant future problem, and more like an active unfolding event. Not dead yet. Not collapsing yet. But clearly changing. Clearly unstable. Clearly forcing scientists to ask the same unsettling question again and again. How close is this star to the end? That uncertainty is what makes Betelgeuse so haunting. Not because we know the explosion is imminent, but because we no longer feel completely certain that it is safely far away in time. The Great Dimming no longer appears to be a simple cosmetic event. The violent mass ejection looks more serious. The disrupted pulsation cycle feels more ominous. The expanding dust structures observed in infrared make the star appear increasingly unstable. Betelgeuse no longer feels like a quiet future supernova. It feels like a star rehearsing its own death. And maybe that is the most unsettling part of all. If the final collapse does happen during humanity's lifetime, Earth will not face extinction. It will face something stranger. The chance to witness one of the greatest astronomical spectacles in history. A nearby supernova bright enough to transform the night sky. A familiar constellation permanently altered. A dying star visible even during the day. The universe reminding humanity that the heavens are not fixed. They evolve. They explode.